Hi, I'm Chris Napoleon from Napoleon Engineering Services, and welcome to this year's Dream It Do It 500. We started the Dream It Do It 500 8 years ago to introduce students to exciting elements of manufacturing, design, engineering, testing, marketing, and more. It's not quite the same this year, but can be just as much fun building your rubber band powered car in your classroom or with your family. Thank you so much for being part of the 2020 Dream It Do It 500. Enjoy.
I'm Mr. Swain from the Envisioneering Center in Portville Central School.
I'm Byron. I've been a Dream It Do It intern for 4 or 5 years. I've been doing the Dream It Do It 500 probably 5 or 6 years now.
For those of you that are not familiar with that, we're going to build and race and market a rubber band powered car.
3, 2, 1.
We're going to start with this kit of parts and pieces.
You're going to have 2 paint sticks, a couple different axle choices, zip ties, popsicle sticks, straws, tape, probably not that much, foam board, a little more than this, and rubber bands.
And you'll also be allowed to use some stuff from around the house. So if you have some items that you want to use to enhance your design, you're welcome to do so. An important aspect of designing your car is going to be creating a blueprint. Now, a blueprint is a drawing that's going to show everything that you need to do to build that car. You're going to want to start with a sketch. That's just a rough drawing. Like everybody knows what a sketch is, right? You just visualize what you want that car to look like, and then you're going to turn that sketch into a detailed drawing that's called a blueprint. And on the blueprint, it's going to look quite similar to this, and it's going to show all the parts that are required for you to build your car and where to put them. And you might want to put some notes, like you need to fix that wheel to that axle, things like that. You want to get all the details so that you'll be able to document that and turn that in.
I'm going to start off here with these 2 popsicle sticks. I've got a piece of tape here. You can use a piece of paper, anything that has a straight edge for a reference to make sure I get these guys nice and parallel.
Is ensure that you have enough structural integrity. That means your car is strong enough to endure you stretching that rubber band as tight as you can. The tendency is going to be for that rubber band to pull your chassis together. This one has some nice wood as a support, so it doesn't bend.
Now what I want to do is I want to get some cross pieces throughout here to hold these guys parallel. So what I'm going to do is I'm going to make sure I'm still up against my reference material here so that that's, nice and perpendicular, which translates to parallel between the two. So I'm going to take this first popsicle stick here, making sure that I'm parallel. I'm going to grab a strip of tape.
So when you're going to build your chassis, you want to consider where you're going to hook the rubber band on the front of the car, and that'll be the distance of that rubber band, right? You want to start with it in the relaxed position, right? In what we call the stored potential energy. And then you want to be able to stretch it all the way to its distance without binding up the car.
You got a framework there. So now that you got this, don't use it as a ladder. You're going to move on to getting your axles on.
The axle is going to be this rotating part. Okay, now the axle is going to need to be able to spin, right, freely. So there's going to be places where it's fixed and places where it's free. So the axle is going to have to run through a bushing. When you can put any kind of hole you want, you can use a straw. There's a lot of things you can use to make a bushing, but your axle is going to need to spin freely within that. You're also going to want to leave the center of it open because we need to put a tab, or a cog it's called, to be able to hook our rubber band to so that we can wrap it around that axle, and it's going to spin the axle to propel our car.
So you flip it over, so you're at your bottom now, and you're going to take those 2 pieces of straw I cut earlier, and I'm going to then just take little strips of tape. I'm going to take this skewer and run it through so it's nice and parallel. And once we got those through, making sure we're nice and parallel, you're going to tape it down. So now, for now, you can remove your skewer. Our back axle, we're going to take our zip ties and we're going to connect them through themselves. And I'm going to be using this with my cut wheels. So this is the thicker dowel. Your zip ties here, cinch them down, not so much that it can't spin. So you see how this is still spinning. So I'm going to bring it in a little tighter just so it's, you know, nice and controlled. But you'll see it's still spinning and still free hanging there. And so you're going to do that twice. And what's really important here is to make sure you keep their rotation the same. So if you'll notice, it comes from this side, goes up, around, and then down. So what I don't want to do is I don't want to flip that around so that it comes from this side, up, around. You want them to be facing the same direction. And so then just get that cinched down there. And so here you go, you've got your two pieces now. And now you're going to want to come on the top here and you're just going to butt this right up against the back of your sticks here, because that will keep you nice and parallel, and it'll also help when you have it on the top. This won't pull down. That's a mistake I've made in the past, so you can take that to heart.
You can see on the model he's used some zip ties to make what's called the bushing, right? On the axle, the wheels are taped onto the axle so that they cannot spin freely on the axle. But the axle can spin freely within the bushings.
Now that we've got our two axles done, we're going to now need wheels, obviously. So I'm going to go through how to make a wheel. So you're going to want to take your cart or your foam board here, and you're going to want to find something circular about the size you want to make your wheels. So you're going to want to trace that out. I'm going to try and get that to reflect. I don't know if it's going to come through on the camera. But once you got that done, your goal is to cut as circular of a wheel as you can. You're going to want to find your center, which you can do by measuring one side, divide it by 2, and find that way. And then you want to rotate it approximately 90 degrees. Same thing, measure across, find half, and wherever those two lines intersect is where you're going to put your X, or where to put your hole. And what you're going to want to do is you're going to want to take your skewer and poke right through that. And then you can see you've got a fairly centered wheel there. Alright, so this I'll just leave on as one of our front wheels. So you're just going to take this, slide it through your two straws, and then pop it on there. Front axle, we have a much smaller diameter than our back axle, and since we used our front axle skewer to poke these holes, we're going to have to make them bigger. So you just want to take it, go into the hole, and just twist it about until you're at about your desired diameter. And do that from both sides.
These places where the wheels are fixed is going to be really important because the axle is going to want to spin within the center of the wheel, or the hub it's called. So you can glue that, tape it, whatever you want to do, but you need to ensure that that wheel is firmly fixed to the axle and that the axle can spin freely within what's called the bushings, okay?
Now to keep our wheels nice and vertical, because you might be able to see our wheels aren't exactly all straight here.
It's going to be very important that the wheels are straight with the axle, or perpendicular. So that's why it shows here it's 90 degrees, okay? The easiest way to do that would be to measure between the wheels in the front and between the wheels in the back, and ensure that you hook them or fix them to the axle with some kind of means that's going to keep them straight or perpendicular to the axle.
I'm going to take a little piece of tape on one side, and then just twist it around. And once you've got that all twisted up, you just pull it in, and then do the same thing on the other side. Make sure to keep it nice and vertical during this, because this is the angle you're going to lock it in at.
One of the things you're going to want to consider is, see this gap right here? This is the distance between the wheel and the bushing. If that gap is too large, your axle will be able to shift too much in one direction or the other. If it's too tight, it's going to cause friction and slow your car down.
Here's something that you will have to do is your axles here, they're going to be sliding all about, and yeah, so you don't want that to happen. So same thing we did with the wheels here, you're going to come right next to wherever your axle mounts. So you see this one mounts right here at this straw. So you just want to make it a little thicker so it can't pass through that straw.
We want this car, our objective this year is to go as far and as fast and as straight as possible. So those are the things we're going to have to do. So we're going to start with a rubber band, okay? A rubber band has what's called energy in it, right? So when we stretch the rubber band out, that's called the stored potential energy. So I have a rubber band here. This is called stored potential energy. We want to transfer that into a force that's going to power our car down the track. So when we stretch that out, we take that stored potential energy and we turn it into what's called kinetic energy, or that's energy in motion. And when I shoot that rubber band, that was energy in motion. We're going to transfer that to our car. And the way we're going to do that is we're going to wrap it around the axle. Okay, the axle is where the wheels hook, and it's going to turn around. And when we make a rotating force, that's called torque. So we want to create torque from the linear energy from a rubber band and turn it into force. We want to get the most power so that we can go fast, but we also want the most linear distance, right? So we want this to go as far as possible. So the first thing we're going to worry about is getting it far and fast, okay? So we're going to transfer the energy from a rubber band into torque to give us the most speed and distance. Now we can do that different ways. If I take one rubber band and I check how much force it takes to stretch that 3 inches, it takes 3 newtons of force. That's the energy that's in that rubber band. And it's only going to go 3 inches. And that will transfer, when I wrap it around, it's going to be the circumference of that diameter. That's going to translate into linear distance. So however far around we wrap it is how far it's going to travel. So the two things I want to do is get the most force and the most distance from my rubber band. So if I take 2 rubber bands and take them the same distance, I start here and go 3 inches, now it's 5 newtons, almost twice as much, right? Now that rubber band has twice as much force, right? But the same distance. I'm also able to take and hook them together this way and increase the length, right? And when I increase the length of a rubber band, it's the same rubber band. Now it travels twice as far. So what you're going to want to do when you're building your car is keep that all in mind, that you want to get the most force and the longest distance from the power that's in your rubber band.
If I just put one of these rubber bands on, you know, it's all right, and then but you see I'm already under a lot of tension here. And so what I'm going to do is I'm going to wind it up backwards. So you want to wind it like your car is rolling in reverse. So if your car rolls that way, when you're going backwards, then that's the way you want this to go. And you twist it up. But see what's going to happen here is it's just going to spin right out.
The number of revolutions is going to translate into what's called linear distance. So the bigger your wheel, because it's the circumference of your wheel, if it's bigger, that will translate into a longer distance. So if you have bigger wheels, your car's going to go farther, but it's more mass, so it's going to reduce the force. So you want to find a balance between the force and the linear distance to get your car to go as far and as fast as possible. If your wheels are too small, you'll have a lot of force. It'll go fast, but it won't go very far. If your wheels are too big, your car can go really far, but it's going to lose force. So you got to find a balance to get the right size wheel. And that'll take some experimenting on your part.
So what you really want to do when it comes down to rubber band is you want it to be a little longer. This is a bit excessive. What you might have wanted to do instead is add in one of the smaller rubber bands here, you know, or if you had hooked up here, maybe this one would make more sense. But you want your rubber band to be longer than, like, from where you're mounting it to your axle. That way you can put it under less tension and still move.
Once you're happy with your design and the build of your car, it's time to go to the track. On the track, we're going to see how far, fast, and straight we can go. So we want to come to the test track and prepare our car. We're going to wind up our axle. Place the nose of the car right at the start line and let it go. But we didn't get any traction. So we're going to try to resolve that problem by putting some rubber bands around the outside of the wheels. Remember, we talked about getting more grip. We hope that that's going to give us more grip when the car takes off. Now you can put rubber bands around them. You can try some other things. If you have some other material you think might grip better, you can try that. Again, we talked about the contact area, so you could try wider wheels. There's a lot of things you can do to try to resolve the problem, but we're going to try rubber bands. So we'll put it back on the start line and we'll release it. You can see that it's still spun a little bit, but much better.
You might want to do next is add a little bit of pizzazz. And so what I've done here, just took some extra foam board and a little chair here, added a little piece I found around the house for my rubber band mount, and added a little storage compartment. So yeah, at this point, just let your imagination run wild. Make sure you have fun, and if you can talk to your friends, get on a FaceTime call maybe, and then have fun.
Thank you for joining us here at the Portville Central School Envisioneering Center. I hope you have fun building and racing your Dream It Do It 500 rubber band powered car. If that's something you're interested in and you like racing, contact Dream It Do It, because we do a lot of other events that are similar. We do the downhill dragster and the soapbox derby racing. So if that's something that you find interesting, contact your local school and ask about joining the Dream It Do It team.